Consider the points R, S, and T. Find the lengths R, S, R, T, and S, T. Can you tell from the lengths whether the points are collinear? Okay, let's find out. We have the point R, which is at 110. So 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's R. We have the point S, which is at 212. So one step over, and if that's 10, then 11, 12. And then we have T, which is at -4, 0. And we'll label that T. Okay, so there's a line that goes from T to R, and there's a line that goes from R to S. Are those the same line? Collinear means, is there a single straight line that goes through both of them? It looks like it from the sketch, within the limits of my ability to draw, but the way we test this for sure is, if you take the distances TR and RS and add them together, they should come out to exactly the same as TS. If that is true, if these come out to, I'm making up numbers here, but if this were 10 and 2 and then the total distance were 12, that would tell us that all those points have to be in a straight line. If instead, imagine if there was a bit of a bend there, you might find this distance is 10, this distance is 2, but the total distance would not be 12. It would be 11.7, something like that. So if those distances do not add up perfectly, it'll tell us there's a little bit of an angle between these lines. They are not collinear. So the test is going to be, will this red length plus this green length add up to the grand total from T to S? And what that means to us is we're going to have to do the distance formula 3 times, which is probably part of the teacher's cunning plan to make us practice. So let's get some distances done. The distance from T to R, the red one, is, you know the formula? It's the square root of x2 minus x1 squared. I'll write it out. x2 minus x1 squared and y2 minus y1 squared. Depending on the formula sheet you look at, you may also see x1 minus x2 and y1 minus y2. Good news, it doesn't matter. You can put these in either order and the distance will still come out right. So as long as you're doing the difference of the x coordinates and the difference of the y coordinates, you are going to be fine. Now from T to R, that means we're going to get 1 minus -4. And for the y's, we're going to get 10 minus 0. That's root 125, which is 5 root 5 if you clean it up. So there's our distance for TR. I'll just put 5 root 5 along that section. Okay, good. Let's do that 2 more times. The distance from R to S is these two now. The difference in the x coordinates is 1 minus 2. And if you feel like leaving this negative sign off, go ahead. It's going to vanish anyway when we square this. So keeping positive or negative signs in this context is not terribly important. For the y coordinates, 10 minus 12, we get -2, another negative sign that's pretty much optional. And from that we get 1 plus 4 root 5. So this little distance from R to S is the square root of 5. Okay, so 5 root 5 plus root 5, these two lengths combined make 6 root 5. So now the question is that the same thing we get if we do the total distance from T to S? Let's find out. We'll say this before we go on. If the total is 6 root 5, then yes, these points are collinear. If the total is anything else, then there's a bit of a bend. These lines are not perfectly parallel, and that'll mean that the points are not collinear. So we'll do DTS and we'll see what the verdict is. DTS is, between these 2 points now, from 2 to negative 4. 2 minus negative 4 is 6 squared. And from 12 down to 0 is 12 squared. That's root 36 plus 144, which is the square root of 180, which breaks up to root 36 root 5, which is, hey, look at that, 6 root 5. So, yes, these points are all collinear as proven from the lengths.